One of the tricks you can do in Java is using inheritance from object. Okay, so you may recall that object is the root class of everything in Java. Everything including arrays. That means any array of any type is an object with a capital O, okay? And therefore, any of those array objects can be stored in an array of type object. That is, okay? So this is kind of a neat thing. This makes the object class extremely useful and flexible if you don't know in advance what type of data you're dealing with. For example, if you have a typical relational database, for example, you might have a table, one or more tables, right? And the table for, say, customers, right? And it might have, as a list of fields, it might have a string for last name, another string for first name, a number for ID, and so on, okay? Dot, 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 and so on. This kind of table, okay, let's shrink it so we can show it blowing up into something. Can be brought into a single object. Okay, so let's call that object O. And then, how would we do this? Well, O itself would be an array of objects, right? So if you wanted to, you could say O equals new object array, right? And we would typecast that to an object. It's kind of weird. Okay, so O itself would be a new object array of, say, however many fields you have. Okay, and each element in that array would be the list of fields, the list of data for that field. For example, right, O1 would equal last names. O2 would equal first names. O3 would equal ID, and so on. Okay, so this object structure and inheritance is a very, very powerful tool that allows you to store literally any kind of data you can describe in Java, you can store in an object. So this object class, it can contain anything. Now you want to be careful when you're doing this because typing is important. If your data is a different type from what your application thinks it should be, things are going to go off the rails. So you do want to be careful about that, but still, this allows you to do some pretty neat stuff. So we'll do a little bit of intro code on this. So I'm going to make a new class. We'll call it, I don't know, KSQL. Okay. And we'll do some fun stuff with that in a moment. So KSQL, imagine for every one of these objects, we'll say this represents a database, right? A standard relational database. Okay. And maybe I'll do an import as well. So import java.util.scanner. Okay, and we might need string tokenizer as well. I'll bring that in. Okay. So in this thing, we're going to have just a single array for table names. That's what we'll start with. So we'll have that be an object, and we'll just have it be an object array called data. We'll have it be names actually for this one. Okay, so this will be our list of table names. And if we wanted to, we could build on that and eventually create a list of data as well. Our actual database data. Okay, so in our constructor, we'll set those to be size 0 arrays. Okay, so we'll have names equals new object size 0 and data equals new object, again, size 0. Okay, so now we get to the part where we're actually going to do some stuff. So we have this data structure. We have a list of table names we can store as objects. We have a batch of actual database data we could store as objects. So what we're going to do in our main method, we're going to create a case equal object. Okay, and within that, we're going to receive data. So we're going to do while true, okay, and we'll create a new command. We'll do k dot get command and k dot process. Okay, it's going to actually do it. So this get command gets the user input via the console, and k process processes the command. Okay, so all we're going to do with this one, we're going to create new table names. So get command, we're going to do this. We're going to store that as a string. So string s equals, and then we're going to process it that way. Okay. So our command will do string get command, doesn't take anything. We'll say system.out.println, please enter a command, and then we'll do down below, we'll do another, we'll put all this in one. Actually, we'll do this down here. System.out.print, and then we'll just do a little bump there to show where people are going to write. Okay, and then return new scanner system.in next line. Okay, so that's the command. It asks the person what they're going to do, and then we're going to process the command. Okay, so the first thing for our process, again, going to be very simple. String command. We're going to use string tokenizer. So here, right, this get command was just very simple. It's just prompt user and return the entered command. In our process method, we're actually going to take that string that the user enters and parse it a little bit. So we're going to parse the command string. That means to look at each little part of it and process it, you know, piece by piece. So we're going to parse the command string to get table names. Okay, so we're going to assume if command equals table, right? So table will be the command for entering a new for creating a new table. Table will be the command for creating a new table. We'll add the new name to the list of tables, okay, which is our array up here, our list of names. Okay, so if command dot equal, we don't want that. We got to do a string tokenizer. Okay, so string tokenizer st equals new string tokenizer command. Now, we haven't talked much about string tokenizer. I believe we mentioned it earlier in the course. I'm going to tell you what it does. Essentially, if you enter a string, suppose you create a string tokenizer object as with a string, the string tokenizer will allow you to extract the sequential portions of the string separated by space characters or other delimiters, right? Boundaries between what are called tokens, sections of the string. So if my original string was, say, the quick brown fox, for each .next token in the string tokenizer, you would get first the, and then quick, and then brown, and then fox. So in this case, if I create a string table 1, right, I can extract those tokens as table, recognize the command to create a table, and then 1, the next token in this way of phrasing it would be the table name. Okay, so I'm saying this is the format of the command I'm going to accept for creating a new table. So first the word table, then a space, then the name of the table. Okay, so with my string tokenizer, I can say if st.nextToken, okay, so next token will return the first, part of the first substring before the space character. If that first part is table, then I can do something, right? I can add the next token, which would be the name of the table, to the new objects. So what I have to do, expand the object array and add the new string. Okay, so I'm going to create a method called, it's going to return an object array. I'm going to call it add, and I'm going to send along as an input an object array and a string. So the object array I'll call O, and the string will be S. Okay, and then at the end, I'm going to return the new larger string. So I'm going to call this method with, I'm going to say names equals add, and I'm going to send along the existing names array and the new token, st.nextToken. Okay, so that's what I'm going to do. I'm going to take this next token, which will be whatever the name of the table is, and the array that I want to add it to, and then the result of that method, this will kick back the new array with the string added on, and I'm going to have the names array point to that. So let's go ahead and do that. Our old method, we make the new bigger array first. So we'll first say object O2 equals new object array with the size of O.length plus 1. Okay, because it needs to be one bigger to hold the string. Then for every element in O, I'm going to create a new corresponding equivalent element in O2. So int I equals 0, while I is less than O.length, and then I plus plus. I'm going to say O2 at index I is going to equal O at index I. Okay. Then the last index of O2, so O2 at O.length, and remember, since O is one smaller than O2, the last index in O2 will be equal to O.length, okay, will equal the string. I'll have a point to that. and then I just return O2. Okay, so here, this method, all this method does, accepts an object array and string as parameters, returns the updated object array with the string added to it. Okay, that's what this method does. So when I call names, I'm going to take my existing array names, I'm going to add that next string to it. And if I wanted to, I could do another command here. For example, I could say, ooh, I don't want to do this. I do actually string t equals st.nextToken. That's really what I want to do. And I say if you have to be careful. Every time you call the next token, it takes one away from the string tokenizer. So you got to be careful with that. I say else if t dot equals, what could I say? Well, I guess that's it. Exit. Then I'll just do system.exit 0. End the program. Okay, and I'll do a display one as well. That's what I wanted to do. I'll do display. Actually, I just call it DT, display tables. Okay, then I'll do a loop through names. So I'll do, I'll call a display method. And here I'll say, this method displays all table names in the object array. So first one, void display, and I'll just cycle through the list of names. So for int I equals 0, I is less than, what is it, names.length, I plus plus. Okay, and for each one of those objects, in order to print it, I need to typecast it to a string. So I could say system.out.println. Okay, I'm first going to do that, plus colon plus, I'm going to typecast it to a string, names at I. Okay, so I'll make a note of that here in the comments. I'll say must typecast the object to a string to print it correctly. Okay. Anyway, so this will all work. Unless I've done something weird, which I don't think I have. Let's go ahead and try it. Let's run it. Let's see what happens. Okay, please enter a command. Okay, and do table 1. Great. New command DT. Aha. Oh, shit. I fucked that up. Let's see. What is the name of it? Here's, I should have done the next token. I had st.nextToken. I got rid of one of them where I shouldn't have. Okay, let's do that. Please enter a command. Table 1, DT. It's named 1. Great. Enter a command. Table 2. Let's list them. 1, 2. And so on. So the neat thing about this, the neat thing about objects, this code works. I'll post it up later. You can play around with it if you want to. Fundamentally, what's happening, I have some stuff stored in memory, right? So imagine if I store a string in memory. Okay. And the string is, for example, 1. I could have an object reference point to it or a string reference, right? So string reference, string S, okay? And that points to it, you know, that could point to it. Or I can have an object reference. For example, object O equals this thing. Now, what makes it a little tricky is if I refer to it through a string reference, it acts like a string. If I refer to it through an object reference, it'll act like an object. So what I need to do to use the string as a string, I need to typecast it to a string. But if I use the object reference, I can store it as an object. And this works because all strings are objects. Okay? Likewise, all arrays are objects too. The same kind of thing works. Okay. Anyway, I'll probably build a little bit on this as the course goes on. This is something we can use as a starting point. But the neat thing about this, if you wanted to store a whole bunch of data in an object array, it's not a problem. This typecasting ability and the fact that any type belongs to object allows you to do this. You can have one array of type object, and it can store data of a variety of different types. We'll definitely get more into this as well later in the course when we cover polymorphism, which is essentially what this topic is. Okay, so that was just something I wanted to show you, something neat that you can do with arrays. And let's see. Other than that, let me ask if there are any questions. If there are any questions about this, I'm happy to address them. If not, we go do a little bit of stuff on coding back. Any questions? Does this all make sense? I hope it does. Okay, well, I'm going to go to coding bat then. Let's see what we can get there. And we will do some basic array problems with loops. Okay, so we should do some of these warm-up ones. We'll get into something a little bit different. So medium array problems with one loop. That sounds good. Let's try it. Oh, there's a bunch here. Anybody want to randomly pick one for me to do? I'll pause the recording while I give people a couple minutes. But okay, here we got something. We got a chat bomb. Not alone. Okay. So let's look at what not alone is. There it is. We'll say that an element in an array is alone if there are values before and after it, and those values are different from it. Okay, return a version of the given array where every instance of the given value, which is alone, is replaced by the larger of whatever's on its left or right. Okay, so I'll pause it for a moment if people want to contemplate this problem, and I will be back. Okay, we are back. So we're going to solve this not alone problem. So the first thing we're going to need to do is basically scan through the array and identify the alone numbers. Alone numbers. Okay, we'll have to do that. We'll have to recognize which numbers, how they'll be replaced. And we have to be careful not to include numbers more than one index separate, okay? More than one index away. And that can happen if we're not careful. So what we should do, okay, is we're going to start off at index 1, if there is an index 1, and we're going to go through to the next to last index. And for each of those, right, we're going to look at it, see which is, see if it's alone. If it's alone, find what number is bigger, copy that into a new array. All right, so first of all, we're going to need a new array of the same size. We're going to do that. Okay, that's the easiest way to do this. So we'll say int array nums2, we'll just call this, let's call this z, equals new int, and the size will be nums.length. Okay, it's going to be the same size. Then we will do well, we'll just start with their values before and after. So we're going to assume that the array is at least 1. Sometimes that's a dangerous assumption to make in these problems. But we'll start here. For int I equals 1, I is less than nums.length minus 1. And then I plus plus. Okay, so if it's at index 0, it can't have a number before and after it. Okay, but for each one of those indexes, all right, so we're going to say here, if nums, we're just going to copy it over. Let's see what happens. So we're going to say z0 equals nums 0. And that might give us an error. I guess we'll see. But certainly the first number will have to be the same, and also the last number will have to be the same. So z dot nums dot length minus 1 will equal nums at nums dot length minus 1. Okay, so the first and last values of the arrays are definitely going to be copied over unchanged. For the rest, we're going to look and see first if they're alone. So check for aloneness. And if they are alone, how do we know that? Well, we're going to say if nums I does not equal nums I minus 1 and nums I does not equal nums I plus 1, okay, then it's alone. Okay, in which case we're gonna say alone update. Okay, the other one we're gonna do otherwise, else we're just gonna leave it as is. Okay, else we're going to say z at I equals nums at I. All right, so this one, if it is alone, what are we gonna do? We're going to say first, z dot I equals nums at I minus 1. And then we're going to say if z at I is less than nums at I plus 1, then z at I equals nums at I plus 1. Okay, so what we're saying here, initially we're going to assume the number before the index we're looking at, the number before I is the bigger one. So we're just going to assign that to z's I element. But we're going to check. If that number is less than I plus 1, then we're going to assign the bigger value to index I. All right, so what we're doing here essentially, don't want to entirely cover up what I'm doing. Move over. There we go. Ah, son of a bitch. I had it for a second. Okay, let's do it like that. Good. So what we're saying is if we have a set of numbers like this, if we had at index I minus 1 is say 4, at I is 6, I plus 1 is at 7. Okay, initially for index I, we're going to say zi, it's alone, right? Initially we're going to say it equals 4, right? Which is, you know, nums I minus 1. But we're also going to check, right? So if this 4 is less than the value of nums at I plus 1, we're going to copy it over. In this case, it would be. So at the end, we'd say zi equals 7. Okay. So let's run it. Let's see if there's some weird thing that got missed here. Missing return. Oh, we got to return the array. Fine. Return z. All right. Now let's try. Yep, yeah, didn't like something there. We had a bunch of mistakes. Did not like some of these. Array out of bounds. Yes, we had one thing where like it was empty. Didn't like that. This one, let's see. So first we're going to say, I guess we'll say if, whoop, first we got to do this stuff. If nums equals null, return null. If nums.length is less than 2, or is less than 3 actually, because we need 3 things to even have one in the middle, I'm going to say return nums. Okay, let's see, that should help some of these. Whoop, I don't want to save that. There we go. That saved a few of them. Saved like the one here with the null array, for example, the really short one. Other tests. Okay, so what is going on here? 1 comma. Oh, and the value. Shit. Well, that's what I didn't do. Okay. Oh, of the given value that's alone. I see. I gotcha. Sorry, I missed that line in the instructions. So we'll say if nums I equals val, and right, it's alone. That should do it, I hope. There we go. Okay, so it pays to read the instructions. All right, if you want, let's take a minute. We'll walk through this one again. So the point was an element in the array is alone if there are values before and after it, those values are different. Okay, return a version of the given A where every occurrence of the given value, which is alone, is replaced by whichever value to its left or right is larger. Okay, so this val is the one we're looking for. As we go through the array, if we find this value, then we replace it. So first thing I check if the if the array is null that I'm getting, I return null. If it's less than 3, there's not enough room for a between to happen, then I'm just going to return the original array. This one, otherwise I'm going to create Z as a copy of nums. You know, these, the first and last values will be the same because they're not going to be between anything. For the rest, right, for all these values in between, first I see if it equals value. If it equals value, and it's not equal to the number before it, and it's not equal to the number following it, then I update it based on that aloneness rule. Otherwise, I just copy this number as it is over into Z. At the end of it, I've completed the copying of the array, and I can just return Z. Okay, so fun with arrays, fun with indexing. Let's do another one. What do you, let's go back. Want to pick another one? Let's see what we got here. Yeah. Mod 3. All right, let's find mod 3. Okay, there it is. Given an array of ints, return true if the array contains either 3 even or 3 odd values all next to each other. Okay. So I'm going to do the same thing I did before. I'm going to check if it has less than 3 or if it's null. So I'm going to say, let's do if nums equals null, return false. Okay, because then it won't have that. Then I'm just going to track a number with this one. So what I'm going to do with this one, I'm going to track a number called repeats. Okay, so int repeats equals 0. And every time a number repeats, I guess I'll start off with that as 1. Every time a number repeats, I'll add 1 to repeats. And if it goes up to 3, I'll know there's 3 in a row. Okay, and then int r value equals, I guess, nums 0 to start with. And I'll assume like we're starting with a sequence of 1 with the first value. So let's do a loop through. So for int I equals 1, do it while I is less than nums.length and I plus plus. Okay, so I'll say if nums at I is equal to our value, Then I'm going to increment repeats. Okay, otherwise I don't, else I'll say repeats equals 1 and R value equals nums I, right? If it's not a repeat, then I'm going to set the repeat count to 1, and the new R value is going to be equal to whatever value I'm looking at in the array right there. Then I check, right? If repeats is greater than 2, return true, right? If I find 3 in a row, then well, they have to be 3 even or 3 odd. Shit. Okay. So instead of being equal, they have to both be even or odd. All right. That's going to modify these things a bit, but the structure is going to remain the same. Otherwise, I return false. So if I've scanned through the entire array and I haven't found 3 odds or 3 evens in a row, I'm going to return false. Okay. So I'm going to do this instead of doing R value, I'm going to do a Boolean. So Boolean odd equals nums 0 modulo 2 equals 1. All right, so this is an expression. I take nums, I divide it by 2. If the remainder is 1, then this expression will be true and odd will be true. If the remainder is not 1, then it has to be 0 and odd will be false. Okay, so that's what I'm going to do here instead of checking for R value. So I'll say if if odd equals this one, right? Put that in parentheses to avoid confusion. Okay, nums I modulo 2 equals to 1. So if true equals true, right, that's great. If true equals false, that'll be false. Okay, so if they're both the same, then that's fine and repeats will go up. Otherwise, repeats is going to equal this Boolean. Right, repeats will equal 1 and the R value, which is now odd, will equal this. All right, so let's see how this goes. Damn it, let's see how this goes. Correct for more than half. All right, so something I did wrong there. What happened? Array index out of bounds exception. Oh, I didn't check for the, what is that? Size 0. Okay, I guess I got to do a size 0 array. Or nums dot length equals 0. Okay. All right, that's it. So yeah, sometimes they'll catch you by they'll send an empty array or a null array, something like that. So here they sent a 0 length array. So this is an example. Remember back when we did conditional statements, this is again an example of short circuit evaluation. So first, I check if it's null. If it's null, then I automatically return false. I don't evaluate this. And that's actually important because if nums is null, I can't evaluate its length attribute. I'll get an error if I try to do that. So short circuit evaluation helps to write a little bit more compact code there. Okay, questions on this, or otherwise I guess we have time to do one more. Let's do one more. Let's go back. We'll do another coding bit here. Let's do one more array for fun. Okay, want to pick one? What do we got?
Lucky 13.
All right, I can live with that. Let's check it out. Given an array of ints, return true if the array contains no 1s and no 3s. Oh, good. Okay. So this would be a very quick one. So what we do in this one, the basic plan, scan through the array. Scan through the array. If we find a 1 or a 3, we can return false, right? Because we know that the array does contain a 1 or a 3. And so if we find one, we return false. Otherwise, if we complete the scan, we can return true. Okay, so let's do it. So for int I equals 0, I is less than nums.length, I plus plus. Okay, and I guess we should do the check here. Same as always, we should say, see, now this is an interesting question in terms, if the array is null, it doesn't contain any ones or threes. And if it's size 0, it also doesn't contain any ones or threes. So that's the phrasing I'm going to go with on this. So I'll say if nums is null or nums.length equals 0, return true, because it sure can't contain any ones and threes if it's null or size 0. Okay. Otherwise, if nums I equals 1, whoop, or nums I equals 3, return false. Okay, if I make it through the entire loop and none of that has happened, then I can return true. Okay, let's see how this goes. Boom. Yay, all correct. Hooray. And they did try to get me with an empty array, but not a null one. Okay, good. So I think this one is pretty straightforward, probably doesn't require much additional explanation. I guess we could do one more. Want to do one more? Let's do one more. Let's see what we got. What do you think? Only 14. Okay. If I can find it, there we go. Given an array of ints, return true if every element is a 1 or 4. Okay. So this is like the same flip around to the same problem we had. So I'm going to do our usual thing. So if every element is a 1 or a 4, so I'll say if nums equals null or nums.length equals 0, then it can't have every element being a 1 or 4, and I'm going to return false. Okay. Otherwise, we're going to loop through, and I'm going to do the thing in obvious. I'm in obverse. I'm going to say if I find something that's not a 1 or a 4, I'm going to return false. Okay. So for int I equals 0, I is less than nums.length, I plus plus. Okay. So if nums at I does not equal 1, and nums at I does not equal 4, return false, right? If it's not a 1 and it's not a 4, then the array doesn't contain only 1s or 4s, and I return false. Otherwise, if I make it through the entire thing, and I've only found 1s and 4s, I return true. All right, let's see how this goes. I missed, what did I miss? Empty array? How'd that happen? It should run false. Oh, see, and this is how they bogus you. Some of these things are total bullshit. So look, right? It says here, if it sends an empty array, a size 0 array, it's saying if every element is a 1 or a 4. Well, you know, that's really a gray area, isn't it? It should say if every element that actually exists is a 1 or 4, but whatever. All right, so we're gonna play it their way. Bogus though. All right, and there you go. That's easy. Okay, but like I said, sometimes they mess you up with the way they phrase the problem. It's a little weird with the empty arrays. Okay. So I guess this is enough time. I feel we covered some stuff. Any questions on any of these things? Any questions on arrays? I hope everyone feels reasonably comfortable with them. The upcoming lab assignment will be around arrays, so you get to code some of this stuff yourself.
I had a quick question about this lab assignment, even though it doesn't pertain to arrays. Are the methods supposed to run? I'm pretty sure that you mentioned something on Monday.
Oh, no, there's no main method, so the program doesn't do anything.
Okay.
Practice writing methods.
Okay, thank you.
Yep, no problem. Yeah, if the class doesn't have a main method, it's not actually going to run. So you need a main method to run it. Okay, good. Anything else? All right, that's all I got for you then. Have a good weekend. See you on Monday. Oh, nums.length is the length of the nums array. So right here, nums.length, that's just how the size of the array. I guess I should stop recording.